Hola, Mr. Sutton here with the IM362 Extra Practice number 4 solutions. This one's for multiplying and dividing rational expressions, and it's got a riddle that goes with it. So let's go ahead and see what that's all about. So here's the puzzle page with the riddle that we're trying to solve. We're asking, why are ancient stories like feet? I don't really know. But what we got to do is simplify these rational expressions, all of which have multiplication going on, no division on this one. And we have to match it up with one of the answers over here on the right. Now, when we do this, whatever letters are part of that answer, we put those letters in the numbers down below. So if I do number 1 and I find the answer is, I don't even know, EY, then I would put an EY in the spots for number 1 right here. So let's go and see where this ends up taking us. Here's our opening problem. Lots of A's and B's floating around, just like every other problem on this. So I think we should try factoring before we try canceling anything out. And that's going to be my strategy on pretty much all these problems. I think they're all kind of at that level of complexity. So in the upper left part of this first fraction here, a squared minus b squared, well, that's literally one of our factoring shortcuts. We can split that up into a plus b and a minus b. That's the formula for that shortcut even. The a to the fourth b is going to stay the same. ab squared is going to stay the same. For this lower right, though, we can take a 3 out of both of those. That leaves me with an a plus b. And now going through and canceling out, reducing what we can, a plus b's can cancel completely. And then these a's in these opposite fractions here, those can reduce. Subtracting my exponents gives me a to the third power downstairs. Now the b's can also reduce, so that's going to give me b to the first in the denominator, or actually the numerator, because I had more b's up there. So going through and picking up what we have left over, we have a b and an a minus b in the numerator. In the denominator, we still have a 3 and an a cubed together. And all of that is right here over on the left side now is where I put it for my PowerPoint screen. That's going to be an EB going in spot 1. So we have an E and a B right there. For my next problem, I've got this mess. I'm going to start by factoring this 4 minus A. It doesn't look very factorable, but I can take a negative 1 out of that. That'll leave me with an A minus 4, which is actually going to fit together with some other things that I'm going to get. The 5A can stay where it is. In the upper right, we can take an A out of those two terms. That leaves me with an A plus 5. And then in the lower right, factors of negative 20 that add up to 1. 1 and 20, no. 2 and 10 doesn't work. 4 and 5 works. Minus 4, positive 5. So A minus 4 and A plus 5 then. Going through and canceling what I can, we have an A minus 4 that's going to cancel. These A's actually are going to cancel out as well completely. And then these A plus 5s are going away. So overall, because I have this negative, my whole fraction is negative. There's nothing else left upstairs, so there's still an invisible 1 up there. And then down here, we only have this 5. So negative 1/5. Easy to spot that in the answer choices. That's EN. So that goes in these two spots. For number 3, it looks like every single part of this is going to need to be factored before I can move forward. So let me start on the upper left. For this, I need factors of 6 that add up to 5. So 1 and 6 doesn't work. 2 and 3 works if I have both positive. So I'm going to write A plus 2B, because I need the b's for this b squared here, and then A plus 3b. Down in the lower left, I'm going to do pretty much the same type of reasoning. Things that multiply to 6 this time but add up to negative 5. So that's pretty easy. That's negative 2 and negative 3. So A minus 2B, A minus 3B. So that's kind of interesting, but there's nothing that cancels so far. Over in the next fraction, upper right, I can take a 10 out of both of those. So that leaves me with an A minus 3B. And then down here we have a 5 coming out. Leaves me with an A plus 2B, or not 2B. So the A plus 2B's are going to cancel. A plus 3B, can't really cancel that with anything, but it would be nice if I could. A minus 2b doesn't cancel anything. A minus 3b's, though, are going to cancel. So we got something out of there. And then the 10 and the 5 can reduce to 2 over 1. So for my numerator, I have a 2 and an a plus 3b. In the denominator, I still have an invisible 1 that I don't care about. We have an a minus 2b, though. I'm going to have to put that in there. So I can find all of that stuff where here. Let's see here. 2a plus 3b, a minus 2b. There we go. TH. So 3 gets a TH right at the beginning here, so T and H. On we go to number 4. Let me start this one by doing a little factoring. So the 6a and the 9a squared can't really do much there, but I can factor my upper left by taking out, it looks like I can take out an a and a b, and that's about it. So that leaves me with a 3a for my first term, and then for my next term, that'll leave me the a's cancel, one of the b's cancels, so we have a minus b there. Still have a 6a down there and a 9a squared up there. But now 9a squared minus b squared, that's an a squared minus b squared kind of situation. So let me square root this and use my plus and minus parentheses. Square root of 9a squared is going to be 3a. Square root of b squared is b, so 3a plus b, 3a minus b. All right, what cancels? So this a here and this a down here can cancel out. I also could have canceled this a with the a squared, but I had to pick one of them. I can't do both. Let's see, this b is all set. 3a minus b cancels with this one here. And it looks like 6 and 9 can reduce to 3 over 2. So what's left over? In the numerator, I have a b and an a squared, and a 3 also that I got from the 9. So that's all up there. And in the denominator, I have this 2 that I got, and also a 3a plus b. So 3a squared b over 2 and the rest of that. Looks like that's right here. So that's HL going in spot 4. So H and L. Here we are on this next one. Lots of factoring to be done here. It looks like from the very beginning, we're going to be challenged. This upper left is going to require the AC method, or at least guessing by checking. So let me try an AC value on this one. 2 times 15 gives me an AC of 30. So I would need factors of 30 that add up to this negative 13. 1 and 30, no. 2 and 15, no, because they have to be the same sign. 3 and 10 works if they're both negative. So let me split this up into 2a squared minus 3a minus 10a plus 15. With 4 terms, I can now use factoring by grouping. So take an a out of those first two, leaves me with 2a minus 3. Out of the next two, I can take a minus 5, leaving me with 2a minus 3. So 2a minus 3 is my common factor. A minus 5 gets to be another factor. And that's what I'm going to put now in my upper left when I start factoring everything else out here. So in the denominator of this original fraction we started with, I can take out, it looks like an a and also a 4. So if I take 4a out of all that, that leaves me with 2a minus 3. That looks like that'll cancel in a minute, but let's keep going. Next fraction. So 6a minus 4a squared. Let's see, that looks a little suspicious because I have higher terms being subtracted. So let me take out a negative, and I'll take out a negative 2a actually. So that'll leave me, this negative 4a squared becomes a positive 2a. 6a becomes a negative 3. Interesting. Let me do one more now. This stuff down here, that's one of those perfect square sandwiches. So I have the square root of a squared and the square root of 25 with a minus in the middle. So that would be a and the minus 5 parentheses squared. If I multiply these and double it, I do indeed get negative 10a. So that works out. All right, what can I cancel? So definitely the 2a minus 3's, I can cancel at least one of those out. So that's good. And then the a minus 5's, I can cancel out one of the a minus 5's down in the denominator. What else? Well, 2 and 4, that's going to reduce to 1 over 2. That's nice. And these a's actually also cancel out. And it looks like that's all that I'm going to be able to get out of this. which I still did pretty well here. So I have this negative that I haven't taken care of yet. Let me move that outside the fraction. That'll make the whole fraction negative. Also in the numerator, I have this 2a minus 3, and that's about it. In the denominator, I still have a 2 hanging around, along with one of these a minus 5s. And I think that's as good as it's going to get. So let me see. We have a negative fraction, a 2a minus 3 up top, and right here we also have the 2 and the a minus 5 down there. So that's EY going in spot 5. So EY. A whole lot of factoring that needs to happen before we can cancel anything out. Let's start with the upper left. So up there we have an a, and I think that's about it that I can take out of there. Only I'm going to take out a negative a because I don't like this negative higher exponent. So I'll take a negative a out of all that. That'll give me a positive a squared minus b squared, which I'm pretty sure I can factor later on. I'm going to hold off on that for now. We have an a squared that's in the lower left. We'll keep that there. In the upper right, I can take an a squared out of both of those terms, and that's about it. That leaves me with an a plus 7b. And then down here, I'm just going to leave this as is because I'm going to factor all that on my next step. Okay, so I've taken out all the common factors I can. Now comes phase 2, where I do a little bit more factoring. In the upper left now, we have the negative a that I took out, and a squared minus b squared, that's literally one of our shortcuts, simplifies to a plus b, a minus b. And then over here on the right side, I have this a squared, a plus 7b that I don't really, can't really do anything else with just yet. But in the lower right, factors of negative 7 that add up to 6. Well, 1 and 7 are really my only options. It would have to be a negative 1 and a positive 7. So I can write a minus b and a plus 7b. And that'll get me that factorization. All right, it's time to cancel out what we can. So this a out in front, I can cancel that out with the a squared. Of course, this a squared and this a squared could also cancel out, so I think I'll do that instead. That's a little bit cleaner. But this a minus b and this a minus b, I'll cancel those out for sure. And then let me take care of these a squareds. Those can go away. And then a plus 7b, clearly I can get rid of those. They're even in the same fraction, so there's not even a question about that. So let's see what am I left with here. I've got a negative a, an a plus b, and I think that's it, nothing else. So negative a plus b is going to be OT, and that's going to be in spot 6 right here, so OT. Number 7 is going to take a little bit of work to factor it. The 15a squared is good the way it is, but the rest of this definitely can be broken down a little bit more. I'm going to start with the hardest part of it, this lower left piece. I'm going to use the AC method because taking out common factors won't work on that. So I have an AC value of 2 times negative 12, or negative 24. Then I'm looking for factors of negative 24 that add up to positive 5. 1 and 24 doesn't work, 2 and 12 doesn't work, 3 and 8 works if I have negative 3 and positive 8. So let me split this up into a negative 3a plus 8a for that middle term. And now that I have 4 terms, I can turn around and use grouping on this. I'll take an a out of my first 2 terms. That leaves me with 2a minus 3. And then for the last 2 terms, I can take a 4 out of those. That leaves me with 2a minus 3. Since I have the same thing twice, I can factor that out. So 2a minus 3, and then the a plus 4 is my other factor going in the leftovers parentheses next to that. And now I can stick that where this expression in the lower left used to be and start factoring the rest of this fraction here. So 6a plus 24, I can definitely take a 6 out of that. That leaves me with a plus 4, 24 divided by 6. Moving over to the right side, this is the difference of 2 squares, 4a squared minus 9. So I can square root that and use a plus minus parentheses for it. Square root of 4a squared is 2a. Square root of 9 is 3, so 2a plus 3 and 2a minus 3. And then the 15a squared is just along for the ride there. All right, what can I cancel out? So definitely the 6 and the 15 can reduce. So that's going to be a 2 and a 5 if I reduce those by 3. And then this a plus 4 and this a plus 4 can cancel. 2a minus 3 down here and up here also can cancel. And it looks like that is it. So in my numerator, I still have a 2 and a 2a plus 3. Denominator, all that's left is this 5 and the a squared. Nothing else is canceling, so let me find that in my answer choices. Let's see here. It looks like I've got it right here, all the stuff with the AR. That's going in spot 7, so AR. And it's looking like I can see a few words here. But let me keep going and just do the last two. For this next one, let me start by taking out whatever common factors I can, and then if I need to factor a little bit more after that, so be it. So in the upper left, I can take out an 8, leaving me with a minus 5. In the lower left, I can factor that a little bit more afterwards, but I'm going to start by taking out a negative 1, just to get everything going in an order that I like a little bit more. So that leaves me with a positive a squared plus 3a minus 40, and I'll factor that again in just a moment. The a minus 8 can stay where it is. Down here I can take out a 2a, leaving me with an a minus 4. And let me keep going now. I'm going to leave everything else the same, except I'm going to factor this stuff in the lower left a bit more. So I still have the negative 1 there. Don't want to lose that. Now I need factors of negative 40 that add up to 7, or 3 rather. So that's going to be, let's see, 1 and 40 doesn't work, 2 and 20, nope. 4 and 10 is not working. 5 and 8 works if I have negative 5 and positive 8. So a minus 5, a plus 8. And now to see what I can cancel out, it looks like the 8 and the 2 can reduce to give me a 4 and a 1. What else? A minus 5s definitely can cross those off. A plus 8 and minus 8 don't quite cancel. They're not exactly the same, so I'm stuck with those. So then just going back and collecting what I've got, I have a 4 and an a minus 8 upstairs. I also have a negative fraction because of this negative 1 I took out down here. So 4 and a minus 8 up there. And down here I have the a plus 8 and an a minus 4. So all three of those things together. I feel like I should be able to cross more stuff off, but I can't. So finding all that, this whole bag of garbage here is going to be a DS, spot 8, so DS. So here we go with the final question. Let me start by factoring the lower left. That's about all we can do factoring-wise. So I can take a 3 out as a common factor to start there, leaving me with a squared minus 2a plus 1. And I can factor that a little bit more. So I've got the 3 that I took out initially. Since I've got a perfect square sandwich there, I can square root the a squared and the 1 and put the sign of the middle term between them. So that's going to be a minus 1, whole thing squared. And just multiplying a and negative 1 together and doubling it, I do get negative 2a, so that actually does work. Let's start crossing some things off. So 27 and 3, I can reduce that to, let's see here, 9 and 1. And then I'll just keep going. I've got an a to the 4th and an a. I can reduce that to a to the 3rd upstairs. B to the 7th and b to the 3rd. 7 minus 3 gives me b to the 4th in the numerator. Down here we have an a minus 1 squared. Up here there's an a minus 1 cubed. Well, 2 of these and 2 of these are going to cancel, leaving me with just one of these a minus 1s. And finally, looking back over here, I noticed that I have a 9 from reducing earlier, and this 9. Hey, why not cross those off as well? So what's left? We have an a cubed and a b to the 4th and an a minus 1 all upstairs. And there is nothing left down here except an indivisible 1 that I don't have to write because it's in the denominator. All of that stuff is right up here, ES. So let me put that in spot 9, and I'm now ready to go through and see what this riddle's answer is. All right, time to solve the riddle. Why are ancient stories like feet? Because they are both leggings. I mean legends, leg ends, legends, you get it. Feet, legs, ends, whatever. All right, till next time, Mr. Sutton signing off.